Cells requires energy to live and do its own task. Mitochondria produces a substance that makes required energy. That substance is called adenosine triphosphate. When a part of itself unbinds, the energy will be released, but that process will turn adenosine triphosphate into adenosine diphosphate. Adenosine diphosphate can be recharged once again to form triphosphate with a process called ATP synthesis, which also requires energy. But we found one interesting outcome when we did some experiment using Suisonia and microbacteria. We added distilled water in 2 test tubes and bubbled only one with Suisonia's gas. After 1 hour of bubbling, we added bacteria in each test tubes and let it sit for a while. We took each samples after 3 hours, 6 hours, 9 hours, and 24 hours to compare survival rates of bacteria by culturing them. In first 3 hours, we couldn't see any difference in terms of survival rate, but results started showing after 6 hours. For the 9-hour and 24-hour sample, the results were obvious. We can clearly see more bacteria have survived with the bubbled water. To further confirm what was affecting the survival rate, the scientists used lumen tester, which can detect the amount of adenosine triphosphate. The results were again interesting. Microbacteria that came from Suisonia's bubble samples significantly showed higher amount of adenosine triphosphate. The important question here was, how did microbacteria survive for more than 24 hours in such an innutritious environment? One factor we can consider is mitochondria may have been actively producing required energy. We still do not know the exact mechanism how Suisonia's team induces ATP synthesis, but for now, we can clearly say that Suisonia was creating an environment for organisms to survive. This may also lead to increased performance for athletes.